kind of stuff. We got to get that squared away now before we get any deeper into the semester. I want to ask you a question. Anybody see that problem? I know I asked a few people this already. Anybody who came in after I said this, what do you think about that problem up there that's on the overhead?
That's gnarly.
Okay. Those of you who were here earlier, just play along with me for a second.
Yeah, that's terrible.
No, you know, on this next part, can everybody close your eyes? Look away. Close your eyes.
I'm scared.
You should be. I can't move that fast. So you're safe from me, but not from the guy behind you. Okay.
All right.
Now look. All right. Can you factor this for me?
No.
How many terms are there?
2.
All right. What numbers come out? How much?
3.
Yeah, 3 comes out, right?
3.
You with me? A tree? How many X's come out? 4. You understand? Is this a hard problem?
Really?
How many Y's come out?
9.
9. How many Z's come out?
3.
Tree. Because what's the shortcut? I take out the smaller power, and that only makes sense physically because, sure, he's got 5. If I try to take 5 of them out, what the hell is he going to do? That's what I call the evil taxman, otherwise known as the taxman. Take more than you got and won't care. So this is at least not taking more than you got. What's left? 4. I had 8, took 4. X to the 4th. I had 9, took them. So they're gone. I had 3, took them. They're gone. Minus. You guys with me? Not bad. How did we do it? We looked at the numbers and we looked at each variable as it came. If you do that, and that's related to the thing I think I told you guys, if you break a problem down into parts, each part is easy. The people that do that naturally, and I was one of those lucky assholes, I naturally kind of do that, so math was easier for me. I can't draw worse shit because I can't do that naturally. I can't see the shapes inherent and so I don't do that. Could I take classes and learn? Sure. Now you guys have to learn, let me stop and break this down. Let me break this down into parts. I don't have to do the whole thing at once. And then of course here, 5. I had 4, took them. I had 11 Y's, took 9, so I got 2. I had 5 Z's, took 3, so I got 2. That's that simple. Now I want you to look at this again. That problem and this problem are the same. I have 8 things I don't know, and over here 4 the same thing. I have 8 things I don't know, and over here I have 4 the same thing. You guys see that? This is more shit in each, but it's still 8 things I don't know. So like, for example, what number comes out? Still a 3. How many X minus 3's can we take out?
4.
Do you see what I'm saying?
Yeah.
Same problem. So this is what I'm trying to get you to understand. When I see X minus 3 as a part of something big, it's one thing. If I knew what X was, that is one number, correct? So it's not any worse than if it wasn't with a minus 3 inside. It was just an X. That's much easier to look at. This is just as easy. It's just not as easy to look at. Okay, maybe. So I'm leading up to a problem that I heard we had some trouble with. I heard it through the grapevine. Let me see. What do I have up here? Shit. Be quiet. Number 48. Pretty sure, even though I didn't hear you perfectly, I got what you said. All right. This poor little dude, did he even want to exist? We don't know. We conjured this guy up. Did he want to exist? I don't know. He's like V6. Existence is pain. We did a problem like this. This is oh crap. What section is this? Yeah. 1.5. 1.5. Yeah, factoring. We did a problem like this. We did several but they had negative powers. This one doesn't have a negative power. What were we just doing? Why did I take out X to the 4th in the one problem? Because that was the smaller power, correct? So what is repeated here? Can I take out a number? Do they share numbers?
Yeah.
What's 9 made of? What times what?
3.
3 times 3. And what's 2?
2.
2. So do they share any factors? No. Good. No, stop. Numbers. They don't share any numbers. Constants, right? The constants don't share anything. How about y's? He's got a y. Does he have any y's?
No.
Good. He's got no y's. Not even that one. He's got a 3y. He's got so many 3 minus 1. Okay. Do they both have a certain number of 3y minus 13s? Good. So they share 3y minus 13s. And in general, what do we take out? The power that is small. So which power is small? 1/5. Shit, Jeff. Can't do it up there. Hey. So I take out 3y minus 13 to the 1/5. What's left? 9y, and we took that out. He took it out. And then, how many of these did we take out? So 6/5 loses 1/5.
Becomes 1.
Becomes 1. Okay. And then, of course, you just distribute your done. Yes? Why did I do that whole problem? Oh well. It's always great to have a math teacher that wants to do every problem. Because like, just ask him a question, maybe he'll do the whole thing. Damn it. Well, I didn't finish it all the way. You guys still have to do something, so I don't feel too bad. But do you guys start? I mean, this is a beautiful example of how a problem can look bad, but it is not. I have 1/5 of this and 6/5, so I can take 1/5 out. They both can give 1/5. The same reason you told me to take 4 x's out, because they could both give 4 x's. It's exactly the same thing. And how do you figure out how many's left? Exactly the same way. It just looks bad, because there's more shit there, but it's the same shit. Who cares? So, it's never going to be perfect, but you guys start to see you have to change the way you look at these things. Okay. Anything else from homework stuff? That's the one I heard about. Yes?
Why 9y minus 2?
What do you mean? So if I take, are you cool with this? Are you cool with us taking this out?
Yeah.
Okay, so if I take that out, what's left in the first term?
9y.
9y.
Okay.
And if I take that out, what's left in the second term is -2, 6/5 minus 1/5, 5/5, 1 whole, yes? It's just what was left. Did I take a 9 out? No, so it's still in there. Did I take a y out? No, so it's still in there. Did I take a 2 out? No, so it's still in there. That's all. So watch. How about this? What, Jeff? I don't freaking know. What about this? How do you factor that?
Okay, z out.
Take a z out. What's left?
9y minus 2, z1. Or
Yeah, why 9y minus 2? Why 9y minus 2? Because that's what's left. I didn't take it out. So why would it not still be in there? Do you see that?
Yeah.
So I made the power a little nicer, but it's effectively the same idea. Okay. All right, maybe. And please don't take it. I try to show you that the problems are not as bad as they seem. I don't mean to insinuate that if you still have trouble with them, this is bad. This means something bad about you. No, it's fine. You can ask me follow-up questions. You can ask me later if you have still some trouble. Let me catch up with. Okay. I think I know she was not going to be here. Yes. All right. Anything else? Anything? All right. So what we're going to do tonight, we're going to focus on finishing chapter 3 from the book, which is module 5 from the lecture notebook. So let's go over module 5 in the lecture notebook together. You're not going to believe this. After that, I've got a handout that I want you to work on. I know, I never do that. We're getting some really, really cool shit, and hopefully we'll see if you at all agree with me. So, let's start with the part that we've actually done some of before, believe it or not.
I love fog.
Oh yeah, fog. So that's always my little joke. This is what students feel like they're in. To be really honest, I have a lot of rants about things that shouldn't exist in mathematics. For example, the radical symbol shouldn't exist. Because we already have like a 1. But this fog, this little circle, should not exist because it is really silly. Oh, plus you guys gotta remind me when I leave shit up here, I'm sorry. Doesn't this make more sense? Can anyone tell me what that means right there? What is being shoved into what? G of x. Beautiful. Because what does f of 2 mean? Take a 2, shove it into f, yes? Right, it's like a little turducken, right? So this one, some of you guys know what turducken is. Well, if I had f of g of h, it might be a turducken. This one says, take g of x, take it, and put it into f. So let's try an example. All right. Anytime I see this notation here, I always think of this as saying f of g, and they just got tired and didn't write the f of the of. You with me? It just makes a lot more sense to immediately write it like this. Then you know what's being shoved into what. Okay. So, for number, yeah, it's a good start, Jeff. For number A, that's beautiful. What does this part need us to do? What's the way I can rewrite this? Because these are 2 parts, yes? I'll say part 1, part 2. What does part 1 need me to do?
G of x.
Yes. Take g, plug it in. What is g of x? Because what's the most important thing for me to know right now is what g of x is. If I know what it is, I can plug it in. So I'm going to replace g of x with what it is. That's all I'm doing. I know wherever I see g of x, I can replace it with 2x squared minus 1. That's all I did was substitute. I know what g of x is. Let me just write that shit down. Oh boy, here we go again. Okay, that was a shorter trip. Nope. Spoke too soon. Go back to me. Thank you. We've done stuff like this before. What do I do now?
Substitute f of x.
No.
Yeah.
No. What do I put into f?
2x squared minus 5.
Yes. And so don't substitute f of x. Substitute x squared minus 5 into f of x. Okay.
Sorry, my English is not.
No, you're okay. You're okay. So then, how exactly would I write that?
So it would be 4 minus 2x squared minus 5 plus 3.
Yes. So the form of a function cannot change. What is the f function form? 4 times stuff plus 3. That's what it is. That's what it always is. I don't care what I put into it. That's what it is. Whatever I put into it, it better be 4 times stuff plus 3. Do you guys see that? So many people get tripped up over function notation. It's just substitution. The x marks the spot. Wherever the x's are, replace it with this other stuff. That's it. Can I do anything with this? Yeah, distribute. What do I get?
8x squared minus 17.
Good, yeah, minus 20 plus 3, so 8x squared minus 17. Okay. Become a 2. Oh shit, becomes you. You guys with me? We've done this. I got you ready for this. G of A. G of B minus 3, I think was a problem we did. Yes, I was getting you ready for this. Oh, what about this second part?
Plug -2.
Where do I plug -2?
To the 8x squared minus.
Yes! I'm sorry, I'll stop yelling. Yes. Do I have an f of g of x function? Yes, it's this, yes? Isn't that what we just figured out? F of g of x is this. That's what it is. So it wants me to do f of g of -2. So I put -2 in.
Now you have no room
Huh?
for the next one.
You got no room?
For the next problem.
Oh, I got you. Yeah, this is true. I'm not good with spacing things out. -2 squared is
4.
4. 8 times 4 is
32.
32 minus 17 is
15.
Now, is that alright? I mean, we've done so much with functions because it's the bread and butter of so much you have to understand function notation, functions, how they operate. This is kind of like the next level. I don't really care too much about this problem. I mean, do you understand how this would, what's happening on part B, just out of curiosity? You take what function and plug it into the other.
Take f of x, plug it into g.
Yeah, take f, plug it into g. Yes? All right. You guys with me? It's the same thing. Here, take a minute. Another sheet of paper if you need to. Figure out what g of f of x is. G of f of x. Take a second to figure that out. I'll catch up to you. Oh, shoot. So remember, these are all available in Canvas, but if you need me to print any of them out, I can. Just let me know ahead of time. I'm sorry, I said we're module 5, but it is page 44. This one is a little more interesting, yeah? You know, like it's a bunch of numbers and letters, yeah, same stuff, okay. Yeah.
That was the right one. Which way switched it?
Yeah, I would square that and then double everything, right?
Yeah.
Sounds good. So you gotta be a little careful, yeah, see, that's where you get in trouble. Because you have to write it twice to square, right? So you lost the middle term, you see what I mean?
Which one?
So if I square 4x plus 3, okay, look at me. If I said right now, piece of paper, I want you to figure out what 18 squared is by hand, what would you do?
8 times
18,
8 times 8. Yeah.
or
You say 8 squared?
18 squared.
Oh, 18
Mm-hmm.
squared. 18 times 18?
Yes, so how do you do 4x plus 3 squared? 4x plus 3? 4x plus 3
Oh.
times 4x plus 3. What am I squaring? What are you squaring? Are you squaring
X
4x?
is supposed to be 16 with x squared.
No, look at me. What are you squaring? What's it say you're squaring?
4x plus 3.
That's what you have two of. You have two 4x plus 3s, and then you FOIL.
Oh, I see, I see.
You see what I mean?
Yeah.
You lost the middle term?
Mm-hmm.
Yeah. Oh, you sure about it? Okay, I got you. Yep. All right, I'm gonna catch up to you guys. So that's the form of G. Twice stuff squared minus 5, and the stuff is 4x plus 3. Yes?
Do you want us to expand that, or is it not? Okay.
So the mistake people make is they'll tell me it's twice 16x squared plus 9 or something. But that's wrong. So what I always give is an example, how would I square 18? If you had to square 18 by hand, what would you write? If I told you square 18 by hand, you'd write 18 times 18. So what's being squared? So what do you write? 4x plus 3. 4x plus 3, FOIL. So you have to have a middle term, right? So you could do it all in one line here if you want to. I mean, once you understand how this works, there's shortcuts. I wouldn't do this shit. But if you're not used to what it's supposed to come out to be, then do this shit. Doesn't matter. So, yes?
Sorry, so then
Oh wait, I'm not even there yet. You guys all with me? So how do I do a function? I take what's in there, I plug it in, and then I do stuff to it. What stuff? This stuff. So we're squaring this bad boy. 4x 16x squared plus 24x plus 9. And then of course what's next?
Distributed two.
Double, yeah? And then you finally get 32x squared plus 48x plus
13.
13. Remind me, what is that? What did we just do?
That's the first part.
No, I mean, true, but what is it? Tell me exactly what that is.
That's G of F.
Beautiful, that's G of F of X. So if they ask me G of F of 3 or whatever the shit, I just plug that number in. I've created the G of F of X function. And now if they ask me a question, I can just plug stuff in. Cool.
Do you want us to factor out the trinomial?
Oh, hell. Yeah. Real quick, guys. Guys, you all have taken math courses. What does it mean when I say simplify? Does anyone know what that actually means?
Reduce?
Say again?
Is it reduce?
Reduce.
But
It's
it's the simplest
basically
terms.
an equation where you equate it, but there's no equal sign.
No equal sign. So in an equation, of course, the first step I do is combine like terms. So you can think simplify means combine like terms.
I'm thinking expression.
More generally, here's what simplify means. Everywhere. It means carry out the operations. What does factoring mean?
To break it down into its base.
Undo operations, right? In fact, you take the answer and you turn it into a multiplication problem that isn't done yet. You guys follow? Simplify is the opposite of factor.
What? Say it.
Simplify is the opposite of factor.
Oh, yeah.
If I said simplify 7 times 5,
35.
if I said factor 35, factor and simplify are the opposites. Cool, okay. So definitely don't try to factor this crazy thing. I want you to simplify it, yeah, okay.
Well, not to be pedantic, not to be pedantic, but the problem doesn't say simplify.
Ah.
So what
It's
that
inherent
means-
in a function problem.
Okay.
That's what it was. The one is simplified as much as possible.
So don't bother factoring.
Because I mean, how do I do functions in general? F of 2, I would plug 2 in and then I would simplify. I try to get to figure out what the thing is.
Well, I guess
So
it's
every time we do functions,
factoring would put you right back where you were. and
Totally.
simplifying
yes.
that. Okay.
Alright,
Got it.
I'm sorry. I'm using those 11-cent words, man. Okay. So that's what we call talking about fancy words. All of this we call composition of functions. Because we say something's composed. If you compose a piece of music, you are infusing it with all kinds of different musical instruments, and so you're layering it all. So composition literally means it's composed of more than one thing.
I fuck with that.
Hmm?
I fuck with that heavy.
You fun with that?
Yeah.
Okay. You fun with composition of music?
Not math.
Oh man, that's even better. I don't get a lot of people tell me they fun with the man that knew. Okay, I don't get to say that too much myself.
Just
Yeah.
candy don't taste.
Now look here, real quick. Can you guys just look at that example 2 and tell me what the domain of each of those functions by themselves is?
Yeah.
No. That's how you get the domain. What are the domains?
X is not equal to 3. I mean, -3.
Okay, so F's domain is everything except -3. So you can say all reals except -3. You can say negative infinity, -3, union, -3, blah, blah, blah. You just have to throw out -3. What about G? Anything except 0.
Fire.
No cap. That's the one. That's the one.
There you go, Jet.
Hello, fellow kids. No, stop. No. I think my niece told me what the hell that meant. Somebody told me something about no cap. I'm like, what the hell are you talking about? All right. So, what does this mean?
G, F, F, and G.
Yeah, G of F. So plug plug f into g, it's trying to be a little x. So I take f. Now, can you guys just take a moment and try to figure that out? If you don't want to, that's fine. You can even draw a duck if you want to, make it look like you're working. I prefer you worked on it. This is not graded, so you don't have to. I mean, you can be as silly as you want to. It's your money, you can waste it. This gets a little trippy. Your brain might balk at what's about to happen, but what do? I replace x with what? No. What am I putting into g? What am I putting into g? What am I shoving into g? And what is f? 1 over x plus 3. So function notation is so single-minded. Whatever in it, you put it in it. Do I have an x plus 3 in g right now? No, I have a 1 over x plus 3. So what am I replacing x with? 1 over x. Okay.
Multiply it by x plus.
Yeah, good. Actually, how do you divide fractions? Multiply by the reciprocal. What is this saying? Keep,
Change flip.
keep?
No, keep change flip.
Keep, change, flip. All right. This is a little mnemonic device. You just multiply by the reciprocal. Yes?
So you multiply the entire thing by the entire thing.
Do you agree with me that another way to write this is -2 divided by 1 over x plus 3?
Yeah.
Yeah.
How do I divide fractions? I multiply by the reciprocal. And then I get. Now, what's trippy is.
Jeff just cooked.
Good, good. Yes.
Why does the negative sign not apply to the second term also?
It does. The whole thing became negative at the end.
Yeah, but why would it be, since the fraction is written negative and then 2 over x, why wouldn't it be -2 divided by -1 over x?
Because I only have one negative. If there were two negatives, they would cancel, and it would have been positive from the beginning. How many negatives are running around in the fraction? 1. So I only have one negative for all of its parts. I could have put it there, and I did, or I could have put it there. I prefer to put it there, because it's easier if it's with the constant, right? Okay. But do you understand?
Yes.
Okay. I don't blame you. That's a really easy thing to get confused about. What's the domain of that function? What's the domain of the function we just created? Sorry, I always point to that.
All numbers.
Say it. Say it.
All
All real
real numbers -3.
numbers except -3. -3 is still a problem. Where did this come from? This. If I make x -3, what happens? The bottom is 1 over 0, which is undefined. So I don't lose values that don't work. We simplify, but this simplification only works if that is valid, and it's invalid in -3. So this is still invalid in -3.
So you couldn't tell by looking at it though.
Not if you just look at the result. If somebody just said, I'm working with this, and then you're like, oh, all real numbers working, like, you're silly, negative. How would I know if you didn't tell me it came from that? But we know the context. I really want you guys, do you agree with me that if I have x plus 3 under anything, then x can't be -3? Does everybody agree with me? Does everybody agree with me? Everybody agree with me? Okay, one at the top is x plus 3. What's x plus 3 divided by x plus 3?
1.
Can x be -3 now? Still no, because if x is -3, I'm still trying to divide by 0. This is 1 as long as x is not -3. In calculus, you will actually talk about, what do I get if I try to put -3 in? What do I get? Tell me exactly. 0 over 0. I don't think this has come up yet. You learn in calculus, that is called indeterminate. some number divided by 0 is some kind of infinity. Yes? If I divide something by small, I get big. Yes? 0 divided by anything is 0 divided by 2, 0 divided by 3, 0 divided by 4. What is that? I have no money, and I distribute it to everybody. How much do we all get? Nothing. So 0 divided by some finite number is 0. You with me? 0 divided by anything is 0. Anything divided by 0 is infinite. So what is 0 divided by 0? It's 0 and infinity at the same time. In calculus, you'll see where that comes from, and you'll figure out how to actually figure out. Sometimes the answer is 0, sometimes it's infinity, sometimes it's a number in between. I just want to point out right now, because it does show up every now and again, where people think, oh, this is always 1. No, x can't be -3. That makes it freaky as shit. It's worse than black hole. It's like the absence of space. And you're like, think about that. What if there was nothing?
What if, never mind.
I can do that. So, I want to do this one example with you guys of a practical, like real life example. So that a stone is dropped into a lake, creating a circular ripple that travels outward at 60 centimeters per second. Holy shit.
Yeah, 60 centimeters per second.
Wow.
Yeah, I know. I don't know. The people that made this. Well, all right. Tell me, 60 centimeters per second. 60 centimeters. How long is a ruler, real quick? It's 12 inches. Do you know, if you ever look to the other side, roughly how long it is? 30 something. So we'll say 30, just because we're American, who cares? So 60 is 2 feet.
In a second.
2 feet per second. I'm sorry, I'm not going to go. You guys kind of follow? To really get a handle on how quick 60 centimeters per second is, you want to put it into something like miles per hour. And you could do that. You could kind of like, you guys kind of with me? Let's just go with it. Whatever this little magical circle's doing, we'll go with it. So, it travels out at 60 centimeters per second. So how quickly is the radius changing over time?
So fast.
So tell me this. If at some time it is 10 across, yes? What's the radius? 5. I wait until, every second. Okay, so 1 second later, the ripple has moved how far? So it's moved 60 more this way and 60 more that way, right? So the radius was 5. Now what's the radius?
65.
65. Are you with me? So as long as you don't think about the diameter, because the diameter would be both directions, I have to double it again. So if I just look at the radius, it goes up by 60.
Yes.
Every one. So right before the stone hits the puddle, the water. I say water weird, so I always have to say H2O or something. High quality H2O. Before it hits the lake, what's the radius of the circle? 0. You guys with me?
Yeah.
Stay with me now.
Sorry.
You're good.
Got excited with
No, I don't blame you. If I say water a lot, people are like, this shit's disgusting. At least I don't say I washed my car. Yes? Okay.
Waste my money.
Let me say this again. Right before the stone hits, the radius is 0.
Yes.
So at time 0, what's the radius?
0.
If I wait a second after it hits, right? If I wait 1 second, what's the radius now? 60 centimeters. Yeah, so can you come up with an equation that represents the radius after t seconds? After t seconds. You can do it. Every second, how much does the radius grow? 60 centimeters. So after 3 seconds, what's the radius? You can do it. After 1 second, it was 60. 3 seconds, it's 180. 4 seconds? 240. T seconds?
60 times t.
60 times t. You, go ahead.
Wouldn't the radius be 30?
No, because the ripple is traveling out 60 centimeters per second in both directions.
So wouldn't that be the diameter? Would be the 60 centimeters?
No. So real quick. If I do 1 second, This side has grown by 60, and this side has grown by 60. It's radiating out at 60.
It's going 60 in every possible
Yes,
direction.
yes. And I tried to just focus on the radius just to get rid of that. Okay. They didn't really. They could have made the problem a little better, but it's okay. It's already kind of. That's one thing you could do, by the way. We are going to get to word problems eventually, which is everybody's favorite, so I'm sorry we haven't gotten there yet.
Wait, what? I'm cool.
But what you can do, if I give myself a number that the variable could represent, and I just see what my brain does. Well, how did I just do that? Could time be 3 seconds? Yeah. What would it be then? 3 times 6. 1 8. Okay, what if it was 4? 4 times 6. Alright, what if you don't know? What if it's t? T times 60. You do the same damn thing. Whatever t is, you multiply by 60. So what is r of t?
60 T.
60t. Yes, ma'am.
I just want to add that T is in seconds.
Yes.
So in some problems, and this is for people going into physics, sometimes you'll see physics will give you a word problem that it'll say like 5 minutes. Convert that to seconds, because T will always be in seconds in physics.
Most of the time.
Most of the time.
Yeah.
Thank you, Maria.
Yeah, we are going to hit some areas where the worst little trick that a problem could do is to have part of it in like feet and another part in yards. And you don't even notice, so you do all the work with the numbers. Yeah. Ask Maria and I, we both, any math major can tell you about a time when they lived through this. Right? A whole quiz I did wrong because I didn't realize the damn thing, you know, it's like, God. I had my calculator set wrong on one quiz and I was like, well, shit, good job, Jeff. Anyway, so we've all been there. Now, I want a function that models the area as a function of the radius. So, do you guys remember the area of a circle? That's the circumference. Pi r squared. Right? Of course, you go pi around, but we'll get past it. I didn't show you guys why. Does anyone remember that? Area is pi r squared? Some of you guys have fallen asleep. I'm sorry. I am boring. Do you guys remember? All right. Have you guys ever seen why the area of a circle is pi r squared?
Yeah, something like that, yeah. I forgot.
If you've never seen it, would you like to know?
Yeah.
Okay, I'll show you. Yay! Do it, Jeff. Someday I'll actually bring construction paper and make this a whole thing. But that ain't tonight, kids. Oh, I still got to get my shirt that says not maybe tomorrow, Satan. I didn't tell you that.
All right.
Maybe tomorrow. Check in with me tomorrow, Satan. All right. So everybody, do this with me. Make a little circle there. Yes?
Okay, forward drawing.
Huh? Yeah, do it. Come on, do it with me. All right. We're not going to get any scissors and all that stuff. I'm sorry. I'm going to tell you what you would do. We'll make it somehow. If I were to cut through the center, yes?
Yes.
So then you have a circle that looks like it's closed its eyes and is not amused. Looks like
Cyclops.
huh?
X-Men.
Cyclops from the side. Sorry. Cyclops. If you cut all the way through the middle, right? So you have two, you can pull them apart. Now, what I'm about to do you guys ever heard of doilies? Where you cut the paper and you open it up and it makes all these. Yes? You don't cut through the edge or else the whole thing is dead. You with me? So I'm going to cut from the center to the edge, but not through the edge. From the center to the edge. I'm going to cut out these little pizza slices. Yes? Okay. So now it looks like the helmet's going to open or something. Does it look like Grogu's little thing? I don't know. You with me? So I cut through, not from to the edge, not through the edge, and I can just pick it up and open it. Does that make sense? I can pick it up from both sides and open it, and it would look like this, roughly. Very, very roughly, because I'm not going to be that careful. Okay. How many teeth should I have? 1, 2, 3, 4, 5, 6, and I have 4, so that's great.
Nice. Beautiful.
I don't know. I'm not good with numbers. Do the same thing with the bottom. Pick it up open it, and shove it in there. And I would fill in all these little tooth gaps. You with me? You guys kind of with me? Now, real quick. You told me earlier the circumference is 2 pi. So how long is this then? Because it was me cutting it in. How long is this? Because that would be the same distance as this. Is everybody cool with that? This distance is the same thing as that top distance, yes? Well, how far is that? Pi r. And how long is each of these teeth roughly? What is this? Radius. What's the area of this rectangle? Pi r times r, which is otherwise known as pi r squared. Okay, so if I take an area I don't know and I reorganize it into a shape I do know, I can get the result. Yes?
Oh, since someone did that with the pizza, that's fine.
The thing with the pizza is area starts going away over time, so you gotta be careful. Sort of like playing poker with Oreos or M&Ms. I suddenly don't have. I'm like, I didn't bet anything, but I'm out of money.
Play poker anyway, you're gonna lose something.
True. Yeah. That's why I try not to mix too much liquor on. Yes.
The circumference is 2 pi, or 2 pi r.
2 pi r.
Okay.
Yes.
And so when you flatten it out like that.
Also, very quickly, do you guys know where pi came from? I'm sorry, I'm doing a lot of asides, but do you guys know where pi came from? No, shut up. Where did pi come from? This pi. All right, here it is. You ready? I don't care how small of a circle you draw or how big of a circle you imagine. If I take the circumference and I divide it by the diameter, I always get the same number. And that's freaked civilizations out. Because before we had Netflix and mobile games, what was there to do besides divide circles, right? So if you take the circumference of any circle in the universe and divide it by its diameter, you always get the same number, roughly 3.1415, blah, blah, blah. Egyptians said it was about 22 sevenths. If you divide 22 by 7, the first few digits are right. That's pretty good for a freaking ancient civilization trying to figure out what pi is. Shit. And you could actually do it. You can take a piece of string, go around the base of like a trash can or something, lay the string out, that's the circumference if you measure it, yes? And then take the diameter of the base of the trash can, divide those, and you get roughly pi. You guys kind of, now, multiply so this we called, it was freaking everybody out. So we gave it a letter. The Greeks are all like, yeah, you want to use, we use Greek letters just because they look neat. That's the drunk history math, but how do I solve that for C? How do we solve this for C? Because now it's basically an equation, isn't it? So C is pi d. And what's the diameter related to the radius? So their circumference is 2 pi r, because d is 2r. Yes? You guys are kind of with me? Okay, well, all of that was a major aside. So, these are all good shit, though. You don't want to just accept this kind of thing. You want to say, why is it that? And if you have a teacher that goes, just take it, and just go, no, do your job. Now, coming back to this. I already told you the answer to this. What's A of R? We already know the answer. You don't need anything from this thing. Pi r squared. Now, here's the neat thing. I like this problem because it's relatively simple. You've all thrown something into a lake. As long as it's not a frozen lake, you can actually watch the ripples go. So, real quick, this is not the time. So you could pass Eddie.
Are you a mandatory reporter?
What's that?
Are you a mandatory?
I am.
Not that they are.
Dang it. Just don't tell me which lake. So, now for part C, this is a real life application of shoving a function into another one. We have an area relative to the radius, but what is the radius doing? Over time it is growing. Doesn't that mean over time the area is growing?
Yes.
That tells me I should be able to rewrite area as purely a function of time. If you tell me a time, I should be able to tell you what the area is. I should have a, right now the area is a function of radius, yes? But if I shove into the area what the radius actually is, and what is the radius? What's the function of the radius? No. for this specific circle, the way it was created, 60t, yes? All right, how do I do this then? Squared. What's 60 squared?
I mean,
No, square.
3600.
3600. And then pi t squared. Is that cool?
Yeah.
Oh, yeah.
So if somebody wants to know the area after 7 seconds, you can just plug a 7 in there, right? It's a one step. Instead of figuring out the radius and then plugging that in to figure out the area, I now have a one step. Now this is a very simple example. This is a nice, simple, hey, I should be able to create a function that relates to this other variable if it's related to a variable that's intermediate. The radius is like a middleman. Radius relates area to time. Bam. Maybe? Okay. You don't have to like it, but if you do, it's great. And then part D is easy as shit. After 2 seconds, what's the area? How would you do that?
3,600 times 4 times 5.
Yep, 3,600 times 2 squared, 4 times 5. Because now we have an area as a function of time. Okay.
Blah, 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 blah.
Oh, okay. Now we're getting to the real meat of things. So that was just a physical example of shoving one function into another. Somewhere in real life you will want to be able to do that. Let me ask you this. The way you want to do this, okay. What does it take to be a function? Can somebody tell me? Pass the vertical line. Kick ass. Where did the vertical line test come from? That really means for every input, there can only be one output. Which kind of makes sense. If I ask you what size shoes are your left foot and you give me 2 answers, I'm worried. I'm like, what's happening right now?
Yeah.
Right? Do you have a little baby shoe inside of a big shoe, like an alien shoe with an alien mouth inside? You watching?
You don't wanna watch it.
It's good. I won't spoil anything. I will tell you, it kicks ass. So far. You guys with me? Sorry about the alien thing. So, one-to-one functions go past that. For example, let me ask you this. I think I've already said that, I can't remember. Now this is overlapping with another class of mine, this is going to trip me up. If I square a number and I get 9, what number did I square?
3.
Nope, you're wrong.
Square.
I squared a number and I got 9. What number did I square? I like what you think, but you're overthinking it. -3, there you go, that's what I squared. Now, real quick, I'm sorry, enough. You stepped right into it. It's like I tell a joke and you came in like, oh no, it's not. Okay. But it's really totally understandable. Of course you're going to say 3, but I need you to start looking at it like a detective. If I see 9, what caused that? It could have been 3 or -3, so I still don't know who did it, right?
Me.
Knew it. That's what's in the lake.
Yeah.
I got you. 7 didn't eat 9. You killed 9 and threw him. Okay. Remind me. Let's make it grab. Where was I? Okay. I want to do this a one-to-one function. Not only does every input go to one output, but every output comes from just one input. That's what they mean by one-to-one. So what would that mean then? Why would this not be one-to-one then? Because this output comes from how many inputs? 2. Do you guys see that? This output comes from this input and that input. Yes? Do you see what kind of test that could apply then? You can basically see what they did. Horizontal line test. Okay. Holy shit. So you got the volt and the hult. The vertical line test, the volt, is to see if it's a function. The horizontal line test sees if it's a one-to-one function. I almost said something. So right now, we know how to test if things are one-to-one. Notice, this is very interesting. This is not one-to-one. Because, just like I said, if I said I squared something and I got 9, you can't tell exactly what it was. There's 2 things it could have been. Now, if I said I squared something and got 0, it's got 1 thing. But in general, it's got 2 possibilities, right? Do you see what they did to correct for that? They just chopped half of it off, poor little guy. Does that pass the horizontal line test now?
Yes.
Yes. Later this semester, we're going to talk about sine and cosine and all that stuff. Even if you've never done any trick, if I say sine wave, can you guys do that in the air? Sine wave. Yeah, it's like this. Yes?
Yeah.
If you ever watch a horror movie, they got oscilloscopes in the back and they got the wave going. There you go. Right? If you ever did any amp, you got any output, you can watch the frequency of the sound. Anybody do any music? And when you crank the gain up and the top kind of gets cut off, yes? Okay. So you can see the actual wave of the sound. Would this pass the horizontal line test? No. But I could chop the domain so that the remaining part passes the horizontal line test. So, what one-to-one relates to? Why does this make sense? If you think about it from a detective point of view, if I did chop this off, and let's make it a normal parabola, just so I can talk about it a little bit more directly. What do I mean by that? One that goes through 0, 0. So if I start with a parabola, and then I chop this away.
Yeah.
Now if I say I squared something and got 9, can you tell me what I squared?
Right.
So now we can be the best freaking detectives ever. Because one clue leads me to one conclusion, 1-to-1. Yes? I need this to make sense. So what we just figured out is, if I give you the output, you can figure out the input. Do you understand how the output, oh, this is going to be so weird to say it this way, I've never said it. The output becomes an input? If I give you that the output is 9, what was the input with this new thing? 3. Like the output was 16, what was the input? Aren't you all taking the number I'm saying as an output, you're doing something to it, and you're getting the new answer. What is it you're doing? 16 goes to 4. Your square root. So what this leads to, if I have a 1-to-1 function, meaning it passes the horizontal line test, that means it has an inverse function. Totally. So, and here's, if I restrict the domain of x squared to be only non-negative inputs, the inverse function, which we denote like this, unfortunately, this symbol means inverse function, is the square root. Yes? So if I input and output from this into this, it gets me back to the original x. So what do I get when I plug a 3 in? I get 9. What do I get when I plug a 9 in? I get 3. Yes? So this function undoes what that function does. If it is 1-to-1, I can figure out how to get back to the original. Does that make sense? That's what the whole idea of 1-to-1 means. Maybe? I want to show you the cool way to get to the horizontal line test. Oh, this is dumb. Sorry. These examples are kind of silly. Is that 1-to-1?
Yes.
Why?
Because it passes the horizontal.
That's the horizontal line. What about this?
No.
That's insane. That's amazing. How did you know that? Okay. So are slightly better examples. For example, what do you guys think about this function? Is that 1-to-1?
No.
No. It just needs a little blip where it kind of comes back on itself like that, and it's screwed. Okay. Is this a 1-to-1 function?
Yes. Yes, it is.
No.
Why is it not?
It's not a
Because
function.
It's not a function.
Yeah.
Oh.
So to be a 1-to-1 function, what do you actually have to pass? Vertical and horizontal. You gotta be a function, and you gotta be 1-to-1. Sorry, I made you step right into that. And I just said I shouldn't anger you, so if I'm not here tomorrow, search all the local links.
Don't gas my number.
Kick the piss, bro. Okay.
So, let me see if you guys are cool with this. If I have two functions that are inverses, what do you think will happen if I take one of them and put them into the other? So let me say it this way. What does this function do to x?
Something.
Multiplies it by 5.
Multiply by 5 and adds 4. If I took that and put it into its inverse, wouldn't all the stuff that we did to x be undone?
Yeah.
So what would happen then? I would end up with x, not 0. I would end up with what I started with, right? So how do you check to see if those are inverses? Plug it in, do it. Oh wait. Does it even matter what you plug into which? No. It'll work. If it works one way, it works both. So pick a way. Take one of the two functions, shove it into the other.
Why would you plug it in instead of setting them equal to each other?
I'm not trying to figure out where the functions have equal outputs. I'm trying to see if they are inverses of each other. What's another way to think of that? Do they undo each other? That's what inverse means. Like a square is an inverse of a square root because a square undoes what a square root does. Okay. As long as you have the domain restricted. So if I do it this way, whatever gets you through. So this will be 5 times stuff plus 4. And you can see what happens.
The 5s cancel.
And then the 4s cancel. So that if that ever happens, then you have two functions, they're inverses of each other. Okay. So if I graph f and g, if I graph them on separate graphs, what would be true?
They're x and y.
They would pass the, oh, I like where you're going, but I'm not quite. They would pass the vertical and horizontal lines. Kick ass. Okay.
Wait, you lost me.
Huh?
If you said you plotted them both?
Yes, if you plotted each one of them, if I plot this one, it'll pass the horizontal line test. If I plot this one, it'll pass the horizontal line test. Yes?
If a function have another function that is inverse to it, that means that function is one-to-one?
Yes. That means they're both one-to-one.
Both.
Yes. Because wouldn't you say, which one of them was the original function? Do we know? No, we just know that they're inverses of each other. So either f is g inverse or g of s is f inverse. Yeah, I like that you're with me. Because that was.
Every function that have an inverse is one-to-one.
If I plug one function in the other one, the answer is x. They're inverses of each other.
And all of those are one-to-one.
Yes, all those must be one-to-one. Yes. Blah, 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 blah. Okay. Let me ask you this, because this is going to become important. Oh my God. I have to use some examples of my own.
Here's my handout,
Okay. Let me think. Yes. Real quick, I'm pretty sure we talked about this, yes?
What?
Cube root? Like, what's the cube root of -8? Do you guys know?
2. -2.
-2, yes. Why does a cube root handle a negative and a square root can't?
Because it brings it back to
3 of them. If I square a real number, can the answer ever be negative?
No.
No. If it's real, the answer can never be negative. If I cube a real number, could the answer be negative? Yes. So that's why cube roots are laid back. Any odd root is more laid back than any even root. It can handle negative inputs. Okay. Huh? Okay. So here's one thing the book, for some reason, this little book, little notebook, here we go. It does sort of get into it, but not really. Oh my gosh. Let me ask you this. Okay. I've got an example like this. Do I want to do it on there? No. Yes, it's good. No. Everybody make this picture with me. Look at this graph. Oh, make this 4.
Great graph.
So basically the same thing? No, good, all right. Can you guys, let's say this is f, yes? Can you guys make a table of values for f based on what I've given you there? Somebody give me a point it goes through. Is that cool? I really label my Jeff. I love it.
My graph is chalk.
Alright, so -3, -1. What's another point? 1, 0. 2, 2. 4, 3. Now, the inverse function. So what does f do to negative 3? If I plug a negative 3 into f, what does it do to it? Makes it become... Don't try to figure out, did it add to... No. Just what is it? If I plug a negative 3 in, what's it become? Negative 1. If I plug a 1 in, what's it become? Now, if I do the inverse function, what is the inverse function's job? It's to take the outputs of f, bring them back to what they were, yes? So what would f inverse of negative 1 be? Okay, so now I can make a table of values for f inverse, yes? What would they look like?
0, 1, 2, 3 and 4.
Tree, yes. If you plot those points, you will have graphed the inverse function, even though we don't know what the hell f was in the first place. I can graph an inverse function if I'm given a graph. I don't have to know. And by the way, I didn't really point this out, but why does an inverse exist for this? Why is it 1-to-1?
That says both the vertical and horizontal lines.
There we go. There's my man learning. All right.
Line colors.
Hell
That's
yeah.
right.
So if you plot these, negative 1, negative 3, 0, 1, 2, 2, and 3, shit, I need one more thing up there. 3, 4. You get this going on. Would you say that's symmetric somehow?
Yes.
What are they symmetric with respect to?
2, 2.
No. In general, where would I put the mirror?
Right there.
I
Yeah.
like that, but I would have hit the board or sneeze. It was weird. Right down there, the y equals x line. Now let me ask you, what did we do to figure out the inverse? We took the x and y and we switched them, yes? You do that all the time. Has anybody ever heard of Nazca lines, by the way? Every time I do Nazca lines, N-A-Z-C-A, down in Peru, there's these lines, and the only way you can see what they make is from the air, really high up.
Oh.
So there's theories about, did they have balloon technology, what the hell, how did they do this and know what they were doing? So there's some of them look like spiders and so forth. Whenever I do this, it looks like Nazca lines.
Can you look at that? Why did that?
When you're working on the worksheet, I'll pull up some Nazca lines, yeah?
Alright.
Or I won't.
Oh, why would you try?
Okay, good.
I regret my decision.
You should. All right. Now,
I'm sorry, bro.
last thing, before I turn you loose on this worksheet. If I give you a function, what you got, Jeff? Okay. Do you guys know what an x cubed looks like?
Yeah, like
Yeah.
Yes, like a snake, exactly. Sidewinder going on. Looks like a parabola, bad roughly. After it fell out, yes. That's on TMZ the next thing. So you got this going on, yes? Does it pass the horizontal line test?
Yes.
All day long? Yes, and all day. So it has an inverse function. I want to find it.
Wait, what?
Not visually, I want to just find the inverse function. I want to figure out what f inverse of x, and I like, right there, I want somebody to say, well, go ahead, Jeff, man. You know how to do it.
Minus
So,
2.
remind me, what part of this expression is y? F of x. F of x replaced y, yes? So the first step is bring y back. We're bringing y back. Okay. Then you do the exact same damn thing we did graphically. What did we do graphically to find the inverse? We switched? All right. Now I do this because I'm weird. I draw a little, I can't help but do it because I'm about to do something that's not algebraic. I'm going to do this. I didn't do algebra to make that happen, did I? I applied an idea. I'm trying to find the inverse function, and how do I find the inverse function? What am I drinking?
Huh. It's in there.
Ice cream. How do I find the inverse function? Didn't make it better. I switch the x and y.
Yeah.
Now, if I solve for, I really want you guys to be with me on this. This is almost dumb. What should the inverse function do? This function adds to. What should the inverse function do? Subtract. This function cubes. What should it should cube? So do you see if I start to solve for y, I start doing all the opposite operations? More importantly, I do the opposite operations in the opposite order.
Yes.
So solve for a y. How do I do that? What's the first step?
Minus 2.
That's insane. Now, how do I kill the cube? cube root.
God damn.
So y equals the cube root of x minus 2. So f inverse of x equals the cube root of x minus 2.
Genius.
Let's check this. What does this do first? When I plug a number in, what's it do first? Cubes it. What does this do last? Cube roots. What does this do second? Adds 2. What does this do first? Subtract. So it did all the opposite operations in the opposite order.
That's a fact. That's awesome.
So let's do the worksheet before all of us go insane from listening to me talk.
Oh, it is. The moment we've been waiting for. It's a moment of truth. It is home. Thank you. Thank you, Mr. Sir.
Welcome.
Thank you, Mr. Sir. Here's my test.
Oh, sweet. What's that? Oh, sorry.
That's.
All right, so because I am an asshole, so
Right, or
let's see. I think I got to a few of you guys, but if all I want is,
Oh, okay.
see, this is gonna work. Should we just do this next time? Maybe we should. Well, let's do this. I'm gonna officially end class because I have that power. Because I want to save the last bit of class for other questions.
Corrections.
So if you have other questions, you can bring them up now. If you want to see some of this, let me know. I will probably, what I'll do is I'll make an answer sheet for this and give it out next time. You with me? Okay. Sort of like, well, you haven't seen a practice test yet, Jeff, so I don't know what that looks like. Okay. So I'll make like an answer key for this. So if you guys have any questions about this, ask away. If you have questions from homework, this is kind of like the replacement for office hours since most of you guys work before class. If you guys just want to keep working on this, that's cool too. So I'll just shut up and find out if you guys have any questions.
You guys are great.
Yeah, no, this is triggering me out.
If anybody wants to work on quiz corrections right now, we have like how many minutes left?
Almost the one, right?
Get those knocked out so they're not hanging over you.
By the way, I love this hours tomorrow.
I wrote it's on here, and then I did
You can also have that.
Yeah. What? What happened? Guys, real quick. If you do quiz corrections, you can come up to me and say, "Hey Jeff, I'm not turning these in. Can you tell me if they look good?" And I'll tell you if any don't, and I will help you if I have time in that moment to get the ones right that don't look good. Isn't that insane? People turn in quiz corrections and they get no points back because they're all still wrong. And it doesn't make any sense to me. Get some help. Okay. Oh, I don't know. Let's see.
I have what I
Just
did
because
on
I
the
can't
other
see
side.
it, but wouldn't it be good if I'm like, I don't know this shit. All right, what's going on here? All right. Yeah, it's gotta be. What did you put? Oh yeah. There is no one. And then X is 2. Output is 4. Oh yeah. Okay. And this should have everything canceled, all the numbers canceled together. Kick ass. So you'll get your 5 back. Yay! That is more true than you know.
So on the little math schedule timeline thing, should we be done with the whole schedule?
No, I'm saying if you're like 3-2 done.
Okay, so we should have all of that.
Yeah, 1, 5, 2, 4, 3, 1, 3, 2. For sure. If you're getting into 3-3, you're really on.
Okay.
We just did 3/47.
Yes.
So it's not a bad thing if you're not quite there.
Because I'm
Yeah,
dividing
so I have
by,
like half of all.
so it's basically
So,
negative one.
we would get this.
Taking out
I mean, you know, like I said, I worked 3 jobs, so I'm like, I had nothing done until the weekend, and then I could get everything done. So
That's probably what I'm gonna do.
physically, I couldn't do it, I could do it.
Yeah, it's, I was doing so much like chemistry and stuff on Monday.
Yeah.
We tried to do it only because, the negative y you can do that. I divided that negative one.
Yeah, totally. And then this side
And then I got
changes.
this, yeah,
So basically, you can't, well, actually, you could in this case, because
More power.
generally you can't bring a negative, you can't bring a constant in. But since it's a cube, you actually,
okay, what do we do if it's not?
well, all you do, are you cool with this point here? What did you do to the door? What operation? What operation is that? What operation you made? You subtracted one. So on the other side, you subtracted. So this should be x minus 1 cubed minus 1. Not times negative 1. You subtracted 1. You didn't multiply it.
You can also add like
No, because.
Alright, Jeff, I'll catch you later.
Excuse me, where's, oh, here. Read this off to me. What's it say? Read it off. What? Keep going. What'd you do? What'd you do right here? To both sides, subtract. On that side, you had x plus 1 cubed, and then you subtracted 1. There it is, there it is. Because you still have a negative here, right? You with me? You did this side, and then you subtracted 1 from both sides. So this side, minus 1. And on this side, of course, the 1's canceled. What's the last thing you have to get rid of? The negatives. Now we're in the same place. Divide both sides by negative 1. When you divide by negative 1, what happens to all your signs? They switch. So then you can write this as positive 1 minus parentheses. Right? So this is currently positive x minus 1 cubed.
Okay.
That's negative x minus 1.
So if it's not a cube or an odd exponent, you put
Then you
the
can't
x,
bring the negative in.
and you
That's
put
why
the x
generally you want to
outside.
be more safe. Yeah.
Because you put the x outside of the parentheses after you do whatever. Because you said put the x outside.
No.
Or no, minus outside.
Yes. So currently right here,
I meant the minus outside.
you're right. This is a positive, right?
Yeah.
So then this becomes positive 1, and this becomes negative parentheses x minus 1. And so then you can just. So, well, yeah.
But the negative is outside. So
If I have-
after-
If I have negative x plus 2 divided by negative 1, what happens? What happens here? No, divided by negative 1. So what happens when I divide negative by negative? Makes it positive. What about positive divided by negative? So if I divide and multiply by negative 1, it changes the signs. So up here, you've got this. So then when you divide by a negative 1, it changes this sign to positive, and it changes this sign to negative. They just, that becomes positive 1 minus this, so I might as well write it 1 minus that, instead of that minus 1.
Mhm. So technically it would just be 1 minus x.
Cube.
Cube, oh,
Yep.
yeah.
And that's the inverse.
Okay.
A little tricky. I agree. Yeah, it can. Yeah, I mean, that's why I always try to easy things. And if it doesn't work out, oh shit. But the book is pretty much gonna make it an easy way, especially with the bigger numbers. Yeah.
It's just like testing that you know how to do it, not trying to like.
Testing that you
trip
know
up.
the right thing to multiply, the right thing to add. Yeah. Keeping track of the negatives.
This one? Alright, so we do that.
Oh, okay. Darn it. I forgot to. So, what sucks about complex numbers? They suck already. They're already weird. They're okay, but we're just not used to them. So it really sucks when I'm dividing by them. That's even worse. You with me? How do I make a complex number become real? What can I do to it? Like, what would I do to I to make it become a real number? Squared. Or better yet, multiplied by I, right? So if you multiply that top and bottom by I, the bottom's not complex anymore, right? Okay, try it. So it's one little thing I forgot to go over. When we talk about all this stuff. Dividing by it sucks, so you basically try to do something to make the bottom not complex anymore.
Oh, because I'm your specific embedded here.
Somewhere there's a. Oh, good. I still have it.
Do you want to staple the sections together?
Oh, this is still recording this.